All right, next video. Not a new idea though. This is the same idea as we just did in the last one, and there's no new ideas. Just a couple more examples. So we are investigating this rational expression. We want to find its asymptote. So first big question: divide by 0. When do I end up dividing by 0? So set that denominator to 0. Solve it. Right? Add 2 to both sides. X is 2. So I know that x cannot be 2. It gives me my vertical asymptote. Great. And then the next question, like I've said before, is what happens if x gets big positively? What happens, that's an infinity sign, as x gets big negatively? Sorry, that's ridiculously sloppy. There we go. And last example, we talked about that special case where this is x to some power, this is x to 1 power less than it, right? The weight is up top and they're only off by 1. That's this case. So when that happens, we actually have to do the division to find the slant asymptote. So what I'm going to do is I'm actually going to do this division. I'm actually going to do this x squared plus x minus 3 divided by x minus 2. And the beauty of it is I can use synthetic division to do that. So when I do synthetic division, remember I use the root of this. I use the 0. So what makes the 0? 2. So 2 is going to go into these coefficients. I don't need any placeholders. I have 1x squared, 1x, and negative 3 1s. So I'll do this synthetic division. Bring down the 1, multiply, add, multiply, add. I have remainder 3. So notice that after I do this division, this was a quadratic, this was a squared, so this is linear. 1x plus 3 1s plus this remainder 3, which is still being divided by that x minus 2. Remember, we're still in the as x gets big. So as x gets really big, this thing tends to 0. Right? If x is really big, 3 divided by a really big number, basically 0. So my slant asymptote is just this without the remainder. It's the x plus 3. It's this line, y equals 1x plus 3. So think about that as a slope of 1, y-intercept of 3, 1, 2, 3, right? Over 1, up 1, over 1, up 1, over 1, up 1, over 1, up 1. So there's my slant asymptote. Just that line, y equals x plus 3. And that's good news. I have my asymptotes in there, frame out where the rest of the shape takes place. I'm going to be lazy. I'm going to grab my graphing calculator and see where the parts fall for this. And since I don't have a graphing calculator, I'll use this. Wolfram alpha. So x squared plus, minus, was it? Minus x minus 3. That whole thing divided by x minus 2. Maybe this one will be a little faster than last time. Oh, it was. Good. All right, I get a nice little offer to upgrade, which I will pass on. And notice I can see right here at 2, there's this asymptote going this way. And then it's going to be the outside parts on this graph. So it's like this. And like that. I'm sorry, I cannot stand that terrible drawing that I just did. I don't know if this is going to be any... It's no better. God, it's so embarrassing. And it's all recorded. You can show your friends again and again what a dork I am. Boom. I know that you get the idea, and I know that... there we go. That's better. So there's a decent sketch of that graph. Again, I'm not going to pay a lot of attention to intercepts right now. I just want to get the frame in. So, gave you a couple of examples. Examples like this. Now's your chance to give it a try. I would like you to try this, to try and sketch this x squared minus 4x plus 1 all over x plus 1. Give that a try. You know it's going to have a slant asymptote, right? Because it has the difference of 1 in there. Give it a try, and then I'll show you how to do it, and then I'll give you some stuff to practice.